Greetings. My name is Michael Hamburger. I'm a faculty member here at Indiana University, and I am a 34-year veteran of the Department of Earth and Atmospheric Sciences, where I've spent much of my career studying earthquakes here in the Midwest of the United States and around the globe, from as distant stretches as the Tian Shan Mountains in Central Asia to the island countries of the South Pacific. I've spent a good deal of time studying volcanic eruptions and tsunamis in the Philippines, and even those mysterious intraplate earthquakes that happen here in the Midwest. What I want to do today is share a little bit of our group's recent work on an unusual secondary effect of earthquakes, earthquake-induced landslides. I want to introduce you to a former graduate student, Nowicki Jessee, now a faculty member at the IUPUI campus in Indianapolis, and Dylan Seal, an undergraduate completing his Bachelor of Science here in the Department of Earth and Atmospheric Sciences. I'll turn the baton over to Anna to tell you a little bit about her global work on earthquake-induced landslides, and then Dylan can tell you a little bit about his current project studying earthquake-triggered landslides in Costa Rica.
Thanks for that great introduction, Michael. Hi, everyone. I'm Nowicki Jessee. I am a lecturer at IUPUI, Indiana University, Purdue University in Indianapolis. And I started working with Michael during my graduate career at IU Bloomington on a model that can be used to estimate the occurrence of landsliding given any earthquake that occurs around the world. Seismic shaking often triggers landsliding, and so the main idea of this model is that we can use information about the surrounding area given the ground shaking that has occurred, and use that to understand how susceptible the region is to landsliding, and then how likely it is that landslides occurred due to that specific earthquake. So these pieces of information are the ground slope, how steep it is, how wet the ground is, the lithology, and the land cover type in that area. We're collaborating with the U.S. Geological Survey on this project, and they are actually using our model results in one of their new tools that they've developed. So I want to show you the tool and how you can get those results here today. So if you go to the USGS earthquake webpage, this is the main earthquake hazards program page for the U.S. Geological Survey. If you scroll down, you'll see the significant earthquakes that have occurred in the past 30 days. Now, they are currently running our model for all earthquakes around the world that are magnitude 6 and larger. So if you choose any earthquake from this list that's at least a magnitude 6 or larger, you'll see the results of our model. So here we see additional information about the earthquake, seismological information about what the ground shaking was like, and a lot of other really useful tools. The one I want to focus on today is the ground failure tool here. Now, this landslide estimate shows the hazard of landsliding for this earthquake and also the expected population exposure for that earthquake. And if we click on this ground failure link, we will find some additional information as well. This estimate here comes directly out of our model that we've developed. And so soon after the earthquake occurs, within minutes to hours, as soon as we know the information about how the ground shook during that earthquake, we can estimate the occurrence of landsliding. And then also they are estimating how many people are likely going to be exposed to landsliding. These results can be really important and useful for many different purposes, such as providing aid to a region, understanding how extensive the landsliding might be. Is it going to affect any main roads or transportation routes or utilities, things of that nature? Also, are there large populations that are likely to be exposed? How quickly will aid be needed and how much? And then also for scientists, this can be useful to quickly see how big of a problem landsliding will be for that earthquake, and to see whether they need to go into the field to map those landslides or deploy additional instruments, and things of that nature. If you click on the View Landslides Map here, you'll also be able to see the spatial distribution of expected landslide probability. And so if you click on this key, you'll see the scale bar, which shows that as you go up through yellow, orange, and purple, you get to higher and higher landslide probabilities. So if you zoom in, you can see that different regions of the map should be expecting higher landslide occurrence than others. And so this model provides a regional scale estimate of the hazard of landsliding soon after the earthquake occurs. Dylan Seal, our undergraduate researcher, is going to explain another really exciting application that can be used with the model, focusing on hypothetical scenario earthquakes.
Hi, my name is Dylan Seal, and I'm a fourth-year undergraduate in the Department of Earth and Atmospheric Sciences, studying earth science, and I have a strong interest in both geophysics and tectonics. I've had the pleasure of studying earthquake-induced landsliding alongside Michael and Anna for the last 10 months, working towards completing my senior thesis, which has been an immensely rewarding and interesting opportunity. My most recent work has been focused on the country of Costa Rica, which is a really interesting place to study earthquakes and landslides due to its extensive and active tectonics, volcanism, highly variable climate, and precipitation, all of which make it very susceptible to secondary hazards of earthquakes like landslides. Through a collaboration that we have with the University of Costa Rica and Rutgers University, we've been able to apply ANA's global landslide model and hypothetical scenario earthquakes in Costa Rica as a means of evaluating both the physical controls on earthquake-induced landsliding and more societal impacts like fatality and damaged infrastructure. We think that scenario earthquakes are a very powerful and underutilized tool in deterministic landslide hazard assessment, so we're really excited for the future of this work and future collaborations with these groups in Costa Rica and with Rutgers.